We've all used one, but have you ever really stopped to think about the absolute genius packed inside a simple petrol pump? Seriously, behind that familiar handle is more than a century of incredible engineering. Today, we're going to pull back the curtain and uncover the hidden world inside this everyday machine. It's kind of hard to imagine now, right? But fueling up a car used to involve actual buckets and open jugs of gasoline. The journey from that dangerous mess, to the safe, super precise pumps we use today is just an amazing story of innovation. So, how on earth did we make that leap? All right, to really get the genius of the modern pump, we have to go way back. Back to a time when filling up your car was a seriously risky business.
So picture this. It's the late 1800s. There are no gas stations. You'd go to a general store, and they would literally scoop gasoline out of an open barrel like it was molasses. Spills were just everywhere. Flammable vapors filled the air, and you had absolutely no idea if you were actually getting a full gallon. It was messy, incredibly dangerous, and just completely unreliable.
Well, the first real solution finally showed up in 1885, thanks to a guy named Sylvanus Bowser. He invented the very first gasoline storage tank with delivery hose. Now, it was just a simple hand-cranked pump, but believe me, it was revolutionary. For the very first time, there was a machine made specifically to safely move fuel from a tank to a car, and that changed everything. Okay, so Bowser's invention made refueling way safer. But it didn't solve an equally huge problem: trust. How could you possibly know you weren't getting ripped off? Think about it. Without any way to check the amount of fuel, customers just had to blindly trust the station operator. This lack of transparency was a massive hurdle, and solving it led to one of the most elegant and clever engineering solutions in the pump's entire history. And here it is, the visible glass pump. The idea was so simple and so brilliant. The operator would physically hand crank the fuel up into this big, marked glass cylinder right at the top. You, the customer, could look right at it and go, "Yep, that's 5 gallons all right." Then they'd open a valve and gravity would do the rest, draining it into your tank. It was a perfect case of seeing is believing, and it built consumer trust pretty much overnight. But, this brilliant solution created its own problem. As cars started taking over the roads, that whole hand-cranking, gravity-draining process was just way too slow. So the next big challenge was, how do we get the accuracy of the visible pump, but with much, much more speed?
The answer was this incredible piece of mechanical engineering, the positive displacement meter. The best way to think of it is like a revolving door, but for liquid. Inside, there's a rotor that turns, and every single rotation lets a very specific, unchangeable amount of fuel pass through. So by just counting the rotations, the pump could measure fuel with amazing accuracy, no matter how fast it was flowing.
So that mechanical meter, a total game changer for speed and accuracy. But the next massive leap forward came from a new power source, electricity. And that made the whole process safer and even more efficient. You see, the early systems used suction pumps up at the top to literally pull the fuel up from the underground tanks. But pulling a liquid is really hard work, and it can create these dangerous vapor pockets. The electric revolution gave us submersible pumps, which actually sit inside the tank underground and push the fuel up. Pushing is so much more efficient, and it dramatically cuts down on vapor buildup, making the entire operation a whole lot safer.
Now, the innovations weren't just in the big pump housing. One of the absolute cleverest pieces of engineering is something we all touch every time: the nozzle. Specifically, its magical ability to just shut off at exactly the right moment.
So how does it know when to stop? It's all about airflow. There's a tiny little tube near the tip of the nozzle, and it's constantly sucking in air. As your car's tank fills up, the fuel level rises, and bam, it blocks that little tube. That sudden cutoff of air creates a vacuum, which then trips a diaphragm inside the handle, and it snaps the valve shut instantly. It's a purely mechanical feedback loop that's all about fluid dynamics.
So that familiar click you hear when your tank is full? Nope, not electronic. That's the sound of pure physics at work. A seriously clever mechanical system designed to protect you from a messy, dangerous overflow. So we've gone from visible glass to mechanical meters to that incredible auto shutoff nozzle. The pump evolved through amazing physical engineering, but the final leap? That's what transformed it from a machine into a computer. And you can really see the acceleration right here. For decades, progress was mechanical. Then, boom, The 80s hit, and microprocessors and digital displays arrived, getting rid of those old spinning dials. By the 2000s, pumps were getting connected to networks, integrating payment systems, and running some pretty complex software.
A modern pump is, without a doubt, a smart device. It has an embedded computer that's constantly running diagnostics. It's talking to the bank to process your payment. It's got environmental systems to capture harmful vapors, and it's even performing complex calculations to make sure you're getting exactly what you're paying for.
And one of the smartest features is something called automatic temperature compensation. Now here's why this matters so much. Fuel actually expands when it's hot and contracts when it's cold. So a gallon of fuel on a scorching hot day has less energy than a gallon on a freezing cold day. This system measures the fuel's temperature and adjusts the volume just a tiny bit, so you're always paying for the exact same amount of energy. Now that is a level of fairness the old glass pumps could never have even dreamed of.
I mean, when you just lay it all out like this, the evolution is absolutely stunning. We went from muscle power to microchips, from trusting what you could literally see with your own eyes to trusting algorithmic precision. Every single part of it, the power, the measurement, the safety, has been completely transformed by over a century of constant, brilliant innovation.
And really, in the end, that's what a humble petrol pump is. It's not just a machine, it's a silent symphony of physics, chemistry, electronics, and of course trust, all working together perfectly every single time you fill your tank. So the next time you're at the pump and you hear that click, maybe you'll think of Sylvanus Bowser's very first pump, or that ingenious auto shutoff nozzle, or the smart tech that's compensating for the temperature outside. It really makes you wonder, doesn't it? What other everyday objects are out there just hiding their own secret history of genius?